Welcome to CS207 Lab number 6. Today we're going to be doing motors. It's really exciting because this is your first step to building a real robot which will be able to dominate the world. Of course, it is my responsibility as a maker and laboratory instructor to tell you that taking over the world isn't good and killing people is also very bad. So don't do that. Instead, use your robots to make love and peace. I did a summer camp where I had kids dance with robots. It was originally just like, let's solve some mazes. And I'm like, wouldn't it be great if we could have a whole bunch of robots dance together, something like this.
He's doing a solo right now.
Okay.
And if I'd had time, he'd be singing a little song at the moment.
But and so this is what you have the opportunity to do over the summer in the computer camp.
Yes.
Look at this.
And then I said, maybe we could dance with our robots, something like this.
I just want to be the one you love. I like bread and butter.
These were like grade 9 students at a summer camp. It didn't turn out fantastic, but it was a lot of fun. Don't expect to be making robots quite at that level from scratch. The motor circuit we're going to be learning today is not the most powerful one and not the most capable one. You'll see a better kind of a motor, an all-in-one package next week, and I will give you some tips on how to drive your motors better through links in the lab, but you'll have to do that learning on your own. For today, we're just going to use a temperature sensor, which we introduced last week, to turn a motor on and off in response to changes in temperature. So I've got my little motor here, and I have taped a little paper flag onto the top with just some household Scotch tape. And this temperature sensor over here is going to let me turn on the motor when I get to 25 degrees. Woo! And now I can cool it off to get below 25 degrees. Takes a bit. There we are. Once again, I'll use my finger to bring the temperature up to 25 degrees. Now, of course, you can't see these temperature changes happening. You can only see the effect on the motor. But you will have serial printouts that give the temperatures in both Celsius and in Fahrenheit so that Canadians and Americans can both understand what temperature it is and whether the motor is going to turn on, and maybe even have a chance of setting their own temperature for their fan. So that's our goal today. You're going to use functions as part of your programming, functions to convert your analog inputs from the temperature sensor into volts, which is a necessary step to calculate degrees Celsius. You can calculate degrees Celsius however you like, so long as you have a function that can take analog and turn it into volts. And then you're going to write another function that will convert Celsius into Fahrenheit. And that's pretty much it for the exercise. I'm going to take a moment now to tear this apart and build it back together again with the first build code so you can understand how the motor will work.